I think the fundamental source of friction was the assumption that we're trying to compete with the data integration and model integration layers, right? So the idea that, hey, I've invested in my existing databases, data lakes, data warehouses, the Snowflakes, the Redshifts, the GCPs of the world, and therefore I can't use Palantir, I can't use Foundry. Whereas from our perspective, it's like all the value is in extending, like you said, past sort of data storage into operations.
All right, so today the second video that I really wanted to hit or cover was these personal interviews that Alex Karp is doing with different speakers or different employees, key employees at Palantir. This is more of a deep dive into what's going on in the role of this employee at Palantir. So I'm going to hit the play button. Some of these videos are quite long, about 15-16 minutes. So if you do have time, make sure to stick around. I'll hit the play button, and then after I'll share my thoughts, or we can go through it together. So right now I'm just gonna watch the first video. It's between CEO Alex Karp and Chief Architect Akshay Krishnaswamy, who dive into the power of Foundry operating system and how it extends existing data architecture and investments, and how it's poised to support IT teams. See, what I like here is now Palantir starting to realize, even though it's big and bad and it can make a lot of connections with C-suite executives, the buy-in, the sponsoring really needs to happen at the IT team level. Even if business leaders support a deal or support implementing Palantir, if you don't have the buy-in from the CTO and the CTO's teams, or the chief technology officer, or the chief innovation officer, whatever you want to call it, from their teams, then you're going to face a lot of resistance, because you don't want people to feel like they're being challenged, or they're being undermined, or they're being told that they're not good enough and not competent enough to come up with their own solution. You really want the IT teams to be the sponsor, to say, listen, we got all kinds of fires to put out, and we don't have the development time to do A, B, C, D, but we do have a firm that can get it done in a heartbeat, in less than an hour, in less than a few hours, like Palantir has done with many compliance issues for banks in Europe and the US. So let's just use Palantir for Foundry. Palantir's Foundry. So let's just check out the video. Let's see what Akshay has to say, and I'll share my thoughts. Let's go.
So I think like the traditional kind of analytics or data architectures kind of come from a long lineage of saying like the primary problem is data consolidation, right? Data is coming from different sources, and to put it together in a place where I can then access it for reporting or for BI.
So explain just in detail, what does a relational database do? Why is it built for certain things, and why will it break down in it going from read to write? And then we'll talk about how it breaks down in a disjointed world.
Yeah, so relational databases, and specifically data warehouses and what we think of as MPP or massively parallel processing databases, are designed for effectively serving data at low latency to hundreds or thousands of users, where the primary access pattern is I'm trying to read this data, right? So how data is locked, how data is kept somewhat consistent is sort of within the paradigm of saying the primary use case is I'm trying to visualize this data or pull it into another place to then kind of look at it or work with it in a read-only way.
And then now let's just start with the very basic functionality of you have to write, meaning write function means you would actually take insights and put them in the data that are not the ones in the database. Where does that break down? And here we're going to bracket where does it break down in a multi-jurisdictional perspective, where does it break down from an access control, meaning data protection, where does it break down in low latency, so in a classified. We're going to leave those all out for now, but in a very, very simple, all of which we built products for. Which is why we're powering a lot of the Western efforts in intel and defense, but just very, very simple, moving read to write. Why does it break down?
Yeah, so if you think about how data is intended to get into these systems, it's through kind of standard interfaces where there are existing connectors or existing interfaces from other systems. So it's system to system writing, right? The key difference is when you have users trying to write data, typically that happens through updates or inserts that are coming from end users. But there's very limited attribution as to what the user is doing or how they're actually doing that insert or update. There's also like very limited capability to kind of segment out priority as to what users' rights or updates should take preference over others. Like it's very much designed to kind of be a bus of in and out for, I'd say, like pretty coarse types of rights, right? You think about like user rights the same way you think about system rights. So that introduces a lot of peril in terms of, well, how could I potentially overwrite data?
Maybe a different way of asking the question would be, if you didn't have a standardized system to do this and you allowed people to write to the core code base or data, what would happen? And why are they preventing people from doing this? What is the technical challenge?
Yeah, literally the technical challenge is data that's coming in from source systems into these databases are getting stored in directories or tables that will then be modified in the exact same modification schemes by end users. So you could delete data, you could overwrite data, you have no ability to understand why data was modified to a certain extent. And so it's just a lot of orchestration, and a lack of versioning, a lack of lineage means that you can't really allow people to, in a multiplayer way.
Don't know what versioning is. What is versioning?
So versioning is actually understanding over time how did data change, and not just how did it change like today's data versus yesterday's data, but who changed it.
I really like how Alex Karp is able to break that down and let people, try to make these videos relatable to your typical Palantir enthusiast. So it's super cool. And I just realized you guys can see my favorite videos that I actually listen to. So Bill Burr Monday Morning Podcast, Palantir, Swedish House Mafia, they're back on BBC, Mega Hits 2022, Tropical House, Kashmir, sick artist, and obviously the GOAT Jackson. I can tell by the thumbnail. Yeah, Palantir Vision. So that's boom. So let's just keep going.
And from the results of what code or what process changed it. That's kind of the key bit that's difficult. You can of course have a log or a transaction log of data changes.
Another assumption people have is you could just make some kind of app and write it on top of your relational database, and all of a sudden you would be able to do versioning. Why is that? Why is that wrong?
Yeah, so the devil's in the details there, right? So if you have exactly one app or a set of apps where you've built in the processes into those apps or into some middleware where you can actually orchestrate and say this app under these conditions will write into these tables and take preference over simultaneous potential writes from another app, then this can all work at scale, right? But you have to basically put the burden of that sort of orchestration or reconciliation work somewhere in the system, right? Where like you could technically, theoretically extend the database to do some of that, but it becomes a pretty intractable problem if you think about dozens of applications, hundreds of users, all doing writes under different paradigms.
Again, here we're bracketing some of the very important issues that are in the national security context, like how would you deal peering between people who are both allies but not sharing all the data? How would you do this with high latency? How would you do this from space to mud, as we've said somewhat in our jargon? How would you reduce the aperture of the data? So we'll bracket those issues for another video. So just all of which we probably should do. But then, okay, so now we have a basic nascent understanding of why it's hard to write to a database. That how do you solve this problem, and how do you move from read to operational? And then as a last part of this video, what we want to get to is, in the past, we've been viewed as antagonistic to IT programs. And this may, in fact, this is a process, but it's my view that there's been a major shift there where IT programs across the commercial space have done an enormous job in building read extensions onto their database, and now have begun to understand that they're going to have to do write functionality into operations, and in fact, very much poised to buy our functionality in the same way they were poised. They've already built functionality that we built 10 years ago into their enterprise. So first, how do you go from read to write? What is the solution that we've built in the core of our architecture? And then how do you go from write to operational?
So I think the key thing that we did is we built a layer that sits on top of the relational data stores. We assume there's actually going to be many of them. The NoSQL data stores, the IoT data stores, the geospatial data stores, called this ontology, this ontological layer, which actually provides a abstraction point where you're actually able to not just sort of present all of the data in a semantic and kinetic view to end users, but also say this is going to be the mechanism through which you accept writes with all of the relevant metadata required to actually reconcile those rights with the underlying data. And so the ontology provides, in a sense, not just an operating layer.
Why is it hard to build an ontology like this? I mean, first of
Yeah.
all, why is it very, very hard
so the
to
term
do?
ontology is actually not new, right?
Yeah,
in the industry, people think ontology sometimes think
The term
taxonomy.
ontology is a little older than the industry, but in any case, go back to that.
Even in the industry, you're right. Even in the industry, it's like people sometimes think, is this a data model file? Is this a taxonomy? And the way that we've actually thought about the ontology is it has to encompass both data, but also actions and process as well. So I think the key thing is you want to understand not just what is the way in which you need to present data in a governed semantic way to users, so the factories, the trucks, the transactions, the customers, the interconnections, but also what are the legal actions? What are the processes that can be taken with those objects by different user groups? So I can actually modify this work order. I can actually flag this customer transaction. And as those different actions cascade, I'm capturing their consequences in the ontology, but also then pushing them back to underlying systems. And so it gives you sort of this ability to simultaneously model both objects and also processes together.
Yeah. Maybe a little bit of background here. When we entered the IC space, what we discovered was, this is actually sounds like the same problem, but it is actually very different in the IC space, that you would have to be able to index against data sets for both legal and practical reasons. So you would actually be working with the indexing layer, not the underlying data, and that we realized that the actual databases were not set up to abstract out of the databases where the abstraction is actually the reality, but you have to disambiguate the abstraction because there are going to be thousands of abstractions inside an enterprise that have to work together. And then we brought that to Foundry. Okay, so you assume you have the ontological layer and it allows you to work with abstractions. Why does that allow you to write and then you've already begun to answer it? Why does it allow you to operate against the data, or the data becomes operational independent of what you're doing?
Yeah, so the key thing I think is that the ontology layer holds both.
Oh my God, wait, yeah, okay, this video is really killing me. I cannot keep up. This is super, super technical. I feel like it is perfect for someone who is in the technical space, who is using the software, or who's a competitor who really wants to understand and see the philosophy and the challenges and really break it all down. What I do have to say though is Akshay's attention to detail, his ability to follow Alex Karp, answer those questions, and Alex Karp continuously, keep that banter going and, paying attention to what Akshay's saying and focusing on some of the words and telling him, hey, look, stop. You need to re-explain that in a way that people understand. And here I am, like I speak English just fine and it feels like they're speaking some alien language to me. I'm gonna still try to power through. There's 8 minutes left, but I'm still gonna try to listen to the whole video. But if you are not able to follow what they're saying, like, don't feel bad, because even I cannot really follow what they're saying. I know the purpose of this video is kind of starting to look like, okay, well, what are the challenges in doing things this way or that way, and why are we doing things another way? And it's just so technical, and I would be just lost in my thoughts if I was there, going like this with Alex Karp and just, trying to get on the same wavelength and trying to answer some questions. I would also I would just be focused like, oh, am I moving the same way as Alex Karp right now? Does he like my answer? Like, I would just totally get lost, and I would miss his question. But it's a great video. I could tell that this is a very technical video, and the two people here are really, really intelligent and passionate about what they're talking about. So I'm just gonna press play. But if you want to dip now and just go watch my other video on the next interview, go right ahead. No feelings hurt here. All right, let's go.
The objects and the relations, but also it holds the actions as well. And by way of doing that, it not just captures how actions can cascade across other parts of the ontology, but also says what are the mechanisms through which we could capture those rights reconcile them, make sure they actually are approved, and then push them to other systems. And so you actually have a buffer where you...
Here, by the way, you're adding in how an access control model works against the abstraction layer. You should probably talk about that further.
Yeah, and I think that's critical to why the writes can work.
Yeah.
So the fact is, like, there is no write happening in the ontology layer, either from a system coming underneath or from an end user coming back, that isn't going through the access control model. So this is a combination of group-based access controls, which could be integrated with the existing enterprise systems, classification-based access controls, and also purpose-based access controls.
And by the way, without going into my macro thoughts once again, obviously, if you were building something for a disjointed world where jurisdictional sovereignty was more and more important, you were sharing data across jurisdictional sovereignty, but only according to the rules where you're allowed to do it, you would need a robust ontology and an access control model. Any case, so that's the reason we spend a lot of time working on this. Okay, so let's move quickly to, or let's.
Well, yeah, that is something that's key. I mean, we can't take it for granted, right? Like, we can't take it for granted that just because allies, Western allies like US, Canada, and European allies, we're all in NATO, or most of them are. We can't just assume that everyone's free flowing, sending data to one another. People have different types of interests. They're only willing to share maybe what they are willing to share and not more than that. There are some countries like Hungary that's in NATO, but it's also like borderline, maintaining a good relationship with Russia, which I can't hate. But, are they going to be willing to share all the data that they want to share? Or do I want to be able to share? Yeah, as a Canadian, or if I was an American, would I want to share all this information with a group that might be close to Hungary and might flow through Hungary and then go straight to Russia? These are things that we have to think about. And that's why, as Alex Karp said, the focus on data, the sovereignty of data, like where it is, where it's hosted, what is shared, and the access to what is being shared is so critical. We can't just take it for granted and just share everything and anything. So, good points.
Let's move to, okay, so you have here, we began in the early parts of our business understanding the limitations of the current, of the data storage, way in which data was stored in software. We moved from read to write to operational. You see this both in our government and in our commercial business, and enormous impact it's having, and will of course have even more in the future. Why was this viewed as being antagonistic to IT? By the way, in government forever, although our business there is so big that it's kind of changed. And then there's kind of a caricature of Palantir that best software in the world. They do a lot of things we don't actually understand, but they seem to be very, very valuable, and someday we will understand them. But is there going to be an absorption of this? So you've seen it in among some of the largest companies in the world, and obviously that's growing, and American businesses like doubled from 50 to 100 to 200. And we see this enormous, these enormous absorption with
It's talking about how commercial revenues grew from 50 to 100 to 200, and their headcount, experienced headcount, was literally 5 to 25. So they were able to grow revenues from 50 to 100 to 200 for Foundry while having a limited headcount for sales. That was experience. So I'm glad that he's mentioning that. Like, I know that by the back of my hand now. It's a big deal. That's what makes me super bullish, because now they have 65 other headcount as of December 31st that are waiting to get trained, that are just eager to get out and kill it. So it's super exciting. Revenues are going to keep growing strongly, in my opinion, and we got to be excited for that.
with a nascent sales force, which is quite, I think, anomalous. 18 years into a business, I don't know any other business that looks anything like this. So just this acceleration, which you don't expect from a business that's been around, which is obviously product driven. But there is this thing, well, is the friction coefficient of the internal architecture, of internal IT structure going to be set? Now, we went through the same thing in government and all over the world, and we've seen how this shifts from being antagonistic to being people's best friends. But what is it in the IT context that has shifted in the last, say, year, and how have we shifted also to accelerate that shift,
Yeah.
and how we're providing Palantir?
Yeah, I think the fundamental source of friction was the assumption that we're trying to compete with the data integration and model integration layers, right? So the idea that, hey, I've invested in my existing databases, data lakes, data warehouses, the Snowflakes, the Redshifts, the GCPs of the world, and therefore I can't use Palantir, I can't use Foundry. Whereas from our perspective, it's like all the value is in extending, like you said, past sort of data storage into operations. And so I think what we've been able to clarify, and I think what we've tried to do a good, like an increasingly better job of, is telling the story of saying what we actually think this ontology-driven approach is, and how the actual software works, which is highly modular, is you can bring your existing data storage, you can bring your existing analytics tools and services.
I'll let you keep talking. It's kind of ironic because, of course, it's not competitive because we built these capabilities almost 10 years ago. So we know where the road is going because, we've already been supplying those kind of things. But in any case, keep going.
I think what we had to clarify, though, is saying, like, okay, even though we provide solutions at those layers of the stack, you can swap in your own if you want.
Yeah.
And I think that's where a lot of our engineering effort has gone as well, is saying, like, how can I make it seamless to come to the table with my existing data warehouse?
Your version is that, but by the way, it's a true version. It's not exactly, to use it, it's not exactly the way I see it. I think it's both true that we probably, because we're primarily an engineering organization and we're not particularly good at sales, have done probably a pretty crappy job of explaining to people how we're not competitive, and probably a great job of explaining to people how we're smarter, which is, whatever, probably not exactly what you're supposed to do. But it's also true, in my view, that there's a learning process that just has to take place. A lot of the issues that IT organizations are dealing with are exactly the issues that we had to discover you're going to deal with. I mean, if you just look at our progression, first we built things that were like data warehouses, so that people could actually get something done, right? So the nascent PG, and then we saw, well, of course that won't work with, so like unless you have these other capabilities, and then we wanted to build it into a robust product, and then we saw if you wanted to work very quickly, you'd have to be able to build a product that you could sew into the architecture, and then we began to understand, well, what are the issues up the chain? And so some of this is our fault, and some of it's just, it takes 5 years of doing these things to actually understand the issues that are coming down the road.
Yeah, and I think that process has actually been underway with the whole cloud transformation too, right? So people have moved to the cloud and I think successfully ported over analytics workloads, right? So instead of kind of the data stores of yore and the MPP databases of yore, they're now using data warehouses, data lakes, and also analytics tools to do the BI and dashboarding stuff. But now the logical question is in the market today is like, awesome, I've done that stuff. Now how do I actually get this stuff into operations? Like what is the way to do that?
Also people are under a lot of pressure because of just general macro events, and that accelerates the learning process.
Yeah, so I think there's I think broadly I think about it as sort of like the difference between knowing you have a problem and being able to act upon it or change plans or kind of like implementations that might already be in place. So like as an example, in utilities, like it's like you might know that you're having like net decreases in power or you have issues that need to be addressed through a public safety power shutoff process, but then how do you actually modulate how you're actually running the assets? Or how do you decide which work around decommissioning of old assets is prioritized first? There's an existing plan in place, which is a read-only view. And you'd be able to update that with new information, not just based on our hypotheses, but what people are doing in the field as well. So there has to be kind of an orchestration of field-driven learnings that are actually building the knowledge asset. And I think that's what's super exciting that we see across supply chain, telco, healthcare as well, is the decisions being made by end users in different contexts is actually the most important data.
And again, on supply chain, why is it difficult? People tend to think, oh, okay, I mean, they watch some movie where people are like, oh, why is this a difficult problem for them?
In the kind of classical world, the ERP and the planning process were all pretty integrated, right? So if you think about where the forecast came from, it was kind of codified in a way that assumed kind of the underlying kind of standard sources were contributing to the forecast. And then, if there's kind of disruptions happening both in the supply and demand side all the time, you say, well, I need to develop a better forecast. Really what I need to do is develop a better forecast almost every day. And so to do that requires different data sources, requires basically understanding which models to use under which circumstances and getting constant feedback from people who are operators using those forecasts. And so it changes from saying, here's the forecast for the month or the week to saying, like, what's the process for continuously assessing what optimal looks like with changing objective functions sometimes across factories or facilities too. So it's just like a very different granularity of problem and also speed of iteration.
Okay, I'm glad I stuck through because I think the gems were at the 12-minute mark and the 13-minute mark. I'm gonna cut through for the video that I'm gonna post on YouTube, but make sure that you listen to that point. They really do highlight something super cool, which is a lot of people compare Palantir to Snowflake, and here we have Akshay saying, well, you know, we have clients using Snowflake and they have their dashboards, they have their insights, but how they're not able to make something actionable. They're not able to simulate what is needed in the real world. You know, I'm paraphrasing, but I found that was super eye-opening. And, you know, that's kind of the experience that I personally had as well before when I wasn't a Palantir believer. I used to think, well, it's just a data analytics tool. You know, I have Power BI. Power BI is free. Well, at least the desktop version is. And what can it do? What can't it do that Palantir can't do? You know, and I was just like, oh, you go screw yourself. But then I soon realized that Power BI had an extension to plug into Foundry, and then I was like, oh, there's something here. And that's what really started my journey in investing into Palantir. It's kind of ridiculous, but that's how it happened. So this was a really good video. At the beginning it was super technical, but it got super interesting at the midpoint mark or near the end. Definitely remember what was said. Rewatch this video, even if it's dry and it's technical, it's boring. It's super important for you to be equipped with how Palantir is different, how it's better, and I really can't help the fact that Alex Karp just can't stop mentioning the fact that, look, we developed all of these modules so many years ago, and now we have these competitors coming up and saying, like, yeah, you know, we can put the data together, we can make a dashboard for you, but they're not at the next step yet. They're not able to see the problems that are going to come, and Palantir's already at that level. So everybody's just going to be chasing Palantir, but Palantir is always going to be ahead. And the other point is how there's so much resistance to dealing with Palantir, but once they do, everybody loves Palantir. So that was interesting. All right, so hit the subscribe button if you haven't already. There are so many of you that watch my video and none of you guys are showing me love, so just please hit the subscribe button. It'll make a big difference for me and my channel that is trying to grow. I do this on my free time after work. I'm doing this because I want to share my due diligence with you, my thoughts, and hopefully you can make the best decision for yourself while you are on your journey to getting what everybody wants, which is a good life with financial freedom where you can just relax and enjoy the moment. So see you later. Peace.